Now we're learning on the device, we're processing on the device, and we're consuming at least 50% less power than other architectures that exist today. So all this functionality in a very efficient manner is where BrainChip's going to start really changing the world in regards to what you can do with your devices.
Welcome to the Conversations on Applied AI podcast, where Justin Grammons and the team at Emerging Technologies North talk with experts in the fields of artificial intelligence and deep learning. In each episode, we cut through the hype and dive into how these technologies are being applied to real-world problems today. We hope that you find this episode educational and applicable to your industry, and connect with us to learn more about our organization at AppliedAI.mn. Enjoy.
Welcome, everyone, to the Conversations on Applied AI podcast. Today, we're talking with Rob Telson. Rob is an experienced sales leader with a demonstrated successful history working in the software and semiconductor industry, skilled in driving growth, negotiation, sales management, organizational leadership, and technology. He holds degrees from the University of Arizona and Harvard Business School, and is the Vice President of Worldwide Sales and Marketing at BrainChip Holdings Limited, a company which is focused on software and hardware-accelerated solutions for advanced artificial intelligence and machine learning applications. So this is perfect, as we love to talk about applications of AI and ML here on the Applied AI podcast. Thanks, Rob, for being on the show today.
Justin, thank you for having me. I'm really looking forward to this conversation.
Likewise, yeah. So I appreciate you taking me up on the offer to join us for a conversation here today. And I mentioned that you're at BrainChip, but one of the things that I do like to ask people maybe is, what was the path to get you to where you are today?
That's a great question. And, I've been really fortunate. I started in the technology space by random circumstance, and I have been in sales my whole career. And I started in the EDA side of the world, so working with software applications to support and build out semiconductors and the circuit boards that go with that. And I've been fortunate enough to work for very large companies and very small companies that have either gone public or have been acquired. And so I've been able to experience a lot of structure and a lot of chaos along the way. But in the last 15 to 20 years or so, a majority of my time was spent through two large organizations, one being ARM, being able to join them through an acquisition, and then get involved in sales leadership there and drive a lot of success as ARM grew dramatically during that time, and run sales organizations for the Americas, as well as in the foundry side of the world and the manufacturing side, and supporting all the partners in that space. And then also through Synopsys and working with them on building out their disruptive technology business and supporting new incumbents coming in, the new players into the semiconductor development space. And as I've evolved in my career, one of the things I've really appreciated is working in structured environments, but also working in unstructured environments and building out organizations, building out models, and really seeing the success, the fruits of the labor turn into something great. And so I've been to BrainChip now for a little over a year and a half. Really, there was no sales infrastructure when I joined the company, and the marketing infrastructure wasn't there at all. And been able to build that out, work with the right people to do that. And now we've gotten to a point where, we've got sales. We've hired a very talented CMO who's joined us and is working out, building out our marketing organization and doing a lot of exciting things on that end, which is allowing me to build out our sales organization and focus on that end as well. And it's a lot of fun.
Excellent. Cool. Well, wow, you were at ARM for quite a period of time. You probably have seen the sort of semiconductor industry really change and evolve over the 10 years or so. What are some things, and it doesn't even need to be technology related, just from the sales side, how has this industry really changed?
You got to put the last 2 years in a box and label it weird when you talk about sales. The whole process of selling in the business that we're in when it comes to developing semiconductors and all the ecosystem around that is really about, this is big investment. These companies that are building chips and going down this path, or actually building products, are spending hundreds of millions of dollars to do so. So finding the right partners that you can trust and you can depend upon and will make sure that you're successful is key. And so demonstrating that you're the right partner to do that, demonstrating that you're going to be answering the phone at 2 a.m. when something in Asia didn't go right and the team in the region that you're in needs to support that, is where it really comes down to play. And so the last 2 years have been weird because having that ability to get in front of new customers, companies trying to adopt technology and build that level of trust through Zoom or through Teams or whatever it is, it's not the same as really sitting face to face and saying, okay, let's map out how we're going to do this. But prior to that, I'll go back to the word that I've used a couple of times here. It's trust. It's really about being able to articulate and quantify the value of trust and selling on that. And knowing that the person sitting across the table from you or the team sitting across the table from you knows that you and your team, not only are they technically capable of doing what you want them to do, but you're going to have their back. And that's, I think, differentiates very successful salespeople and sales organizations and those that struggle to get to that point.
Yeah, it makes total sense. Yeah, I mean, that is really about what a relationship or partnership is trusting that the other person's going to be there. Do you see manufacturing change from Asia, to the United States, at all? Or where do you see things, or is there any advantage to bringing it more onshore?
That's a tricky one, my friend. Especially now, the geopolitical dynamics are as heightened as they've ever been in our lifetime. But you have to go back 50 to 100 years to look at the Industrial Revolution and look at how things have changed. I really implanted themselves as an industrialized nation and a leader in that, and how they took that away from other nations who had their own industry and had their own manufacturing, but then realized that they didn't need to do it. So they depended on countries like the US to do that. And unfortunately, as we've evolved in the United States, we've seen the same thing, where we become dependent upon other regions globally to support some of the manufacturing that we could do onshore in the US. My gut feeling says, based off of the dynamics that are going on today, there will be more requirements where manufacturing is done regionally. So this isn't just a US thing. This could be a global dynamic for each country to be able to have their own manufacturing skill sets and be able to be self-sufficient in the environments that they're in.
Totally makes sense. Yeah, for sure. There's probably not a one size fits all.
Yeah, exactly.
Now, when it comes to BrainChip, and maybe we can talk a little bit about like AI, like I know you guys create basically advanced neural networking processors.
Yeah, this is really cool stuff.
Yeah, sounds fascinating. I want to know more about it.
You just press the go button on Rob, and I'm going to sit and talk for a little bit now. But yeah, so what we do, which is really unique in the business, when you look at AI as of today, most AI is actually processed not on a device, it's processed in the cloud. And then it goes back to the device. And I like to use, let's use home personal assistants or your phone when you talk to your phone and ask it for directions. And you've ever had that experience where it tells you, I'm busy right now, or I can't answer that. Like, I don't get it, right? Basically what it's telling you is I can't get this information to the cloud and back to the device in milliseconds. So give me a second and I'll figure it out. And as technology evolves, more and more demand is going to be put on devices at what we call the edge. These could be battery operated devices, such as a handheld device or even a vehicle. It's battery operated in the future. It could be industrialized machinery and applications where there's a lot going on and around it. It could be medical devices, either in a facility plugged into a wall or out very remote in third world countries where they don't have the electricity to work with. And so all of this ability to drive intelligence into these devices is going to require the ability to do all the processing of the information on the device without being dependent upon the cloud. So as I said earlier, all of the information that's driven today is driven from device to the cloud, back to the device. What makes BrainChip very unique is that we have the ability to do all this on the device without depending on the cloud. So we're going to be processing on the device. The other major addition or major differentiator that we have is that the way we're architected, we're using right off the bat at least 50% less power consumption to do so, which means we're not dependent upon a lot of processing power in order to process the information, which allows us to be in these edge-based devices. Puts us in a very unique position. The third thing that we do that others don't do, and this is where it gets exciting, is that we do OnChip Learning. So now we're learning on the device, we're processing on the device, and we're consuming at least 50% less power than other architectures that exist today. So all this functionality in a very efficient manner is where BrainChip's going to start really changing the world in regards to what you can do with your devices. And the most common talking point right now is in electric vehicles. And it's the common talking point because basically it's a dramatic shift from the traditional vehicle as of today to the amount of compute power that's going into that vehicle. But the drive isn't that the vehicle is becoming more like just a computer on wheels. The drive is, I'm really scared to drive 300 plus miles or 500 plus kilometers because what if I lose my charge? What if my battery dies and I'm out in the middle of nowhere? And that's where the differentiating technologies and the architecture that we're based on, which is neuromorphic architecture for AI, is really going to drive things in a very unique way, because now you can extend your charge. Now you can get 1,000 kilometers on a charge. Maybe you can get 1,000 miles on a charge. Now we're really getting excited when it comes to technology. And BrainChip's leading the way with what we've developed, which is our chip is called Akida. And as I just highlighted, we're based off of neuromorphic architecture. And that neuromorphic architecture means that we're processing our information very similar to how a human brain works. And so you think about the human brain, there's a lot of energy that can be consumed with the way we process information, but the brain is designed not to consume energy. It's designed to process and focus on certain aspects of information at a time, whether that be vision, smell, taste, touch, whatever it is, it knows it's going to consume some energy over here and then consume some energy over there. While the traditional AI engine as of today has to process all this data and information at the same time. And because we're neuromorphic, we're processing where it needs to focus at the time it needs to process the energy. And that makes us extremely efficient, still meeting the performance requirements that some of these semiconductors are going to need to meet to accomplish what they want to accomplish in the future.
Fascinating. Yeah, really, really cool. Thanks for that rundown with regards to sort of how you differentiate yourself. It's funny that you mentioned about also, having to go to the cloud. So I'll share a personal story, right? So I have 2 little kids and they have Alexas in their room and, we use them as alarms, right? So they have to, the Alexa goes off, and very often, just based on where they are in the house, they're a little bit further away from the Wi-Fi hotspot. And so the alarm will go off in the morning and they'll be yelling, they're 8 and 10 years old. They'll still say, Alexa, stop alarm. And it won't stop. And the reason it won't stop is for that exact reason what you're talking about, is it actually is not connected to the internet. They haven't actually built that switch in there, yet, or enough intelligence in the Alexa to understand, you told me to stop, but I need to talk to the cloud to even do something as basic as that.
Yeah, exactly. That's where it gets really tricky. See, I have the opposite. I have fun with the Alexa. One of my teenagers has the Alexa. And, if he's sleeping in, went a little bit further on the weekend than I want him to sleep in, I can stand directly, just go down the hallway, although his door is closed, and I can say, Alexa, tell me a story about Peter the Rabbit. And all of a sudden I'll hear Alexa go, let me tell you the story of Peter the Rabbit. And my son will go, Dad, what are you doing? And I'll just walk away with a smile on my face.
Yeah, that's good. That's good.
I use it to my advantage. So these are the things that we're very excited about, because technology has gotten to a point where there's some really great things that we can do. As I said before, whether it be in the consumer applications, whether it be in transportation, whether it be for beneficial AIs, what we focus on and think of healthcare in a variety of different areas. So it's actually a point where there is this shift going on, and BrainChip's going to be a part of that.
Yeah, for sure. You mentioned brains. There is actually a book called 1,000 Brains that I would suggest reading if you haven't already. And we'll have liner notes and stuff like that in this podcast. So I'll have links to your website and your profile. But it does talk a lot about sort of this idea of what they know today with regards to how the human brain works. And, a lot of it is prediction models is really what they're sort of coming down to. As you reach out and grab this glass of coffee that I have in front of me, for example, your brain starts to anticipate, okay, I'm going to be touching this soon. But, efficiency is always key, per your point. So I think it's really cool how you guys have really taken this idea of creating an architecture that, again, energy is going to be the key to success here probably going forward, especially with remote applications. What are some particular applications? Are you guys in the agriculture space where you're, sensing crops and stuff like that? Or I don't know, maybe fill me in a little bit more on some of these sort of like remote low power usage cases that you see your chips ending up in.
Justin, it's a great question. I want to say we're everywhere. The amount of interest level in our technology and what we're doing, it's extremely broad. We've had some success, for example, with NASA and helping them in regards to getting to orbit and being able to capture images and so on, using extreme low power devices such as Akida, to other success like in the vehicle and working with a German automotive manufacturer and having them utilize our technology to prove out their electric vehicle goals. And they, announced that at CES. And we see that there's a great path there for the future between the two companies, as long as we continue to deliver on what they're expecting us to deliver on, and other vehicle manufacturers as well, all the way to consumer electronics and applications in the consumer space and medical devices from that end. We've had a lot of interest in other areas, as you mentioned, like agriculture and so on. The difference is, the unique thing is, as with any business, you have to focus on the areas where you can generate revenue. And so time to money is always a critical component to when we're talking to companies, what we're trying to accomplish, as well as, wow, that's a really cool idea. And so you have to be able to balance what are really cool ideas that will actually come to fruition and applications that you can successfully leverage your technology and be able to communicate to the world that your company is a success. So you have this balance. And one of the unique things for BrainChip is, we funded our company, we took it public, and we are publicly traded on the Australian Stock Exchange and also in the US, as well as, I believe, on the exchange in Germany. So we have a very strong following and a lot of shareholders that are extremely passionate about the success of this company. And so we have requirements to go out and achieve success in the short term, but we also have to strategically put the right engagements in place for the long term as well.
Yeah. So you're dealing with, say, I have a company, I have an idea, I want to build a smart coffee cup, for example, let's say, some widget or something, and then I approach you guys and say, hey, how can I buy your hardware? But you guys must have some software and a software application stack on top of it as well. Like how much do you guys then are engaged?
So our main focus, to be very straightforward, I'm going to take this sideways and bring it back. It's all going to make sense in a second. Our main focus is on licensing intellectual property. So basically what we're trying to do is take our Akida technology, license it as IP to be designed into an SoC around a broader system. And we've had some success doing that. We've engaged with Renesas. We've also engaged with a partner in Japan called Megachips, who is an ASIC design house and have had a lot of success with Japanese customers in that space. And so we're building that business out. In order to drive the software dynamic of it, companies develop their AI models and their networks in convolutional neural networks, or CNNs. And those CNNs can be built off of TensorFlow. They can be built off of PyTorch or whatever. And so what we do is we have a software development flow that takes companies that develop their own CNNs, and then we optimize it into what's called a spiking neural network environment. So because we're functioning like the brain functions in spikes. So these are called SNNs. And so we have that whole software development stack. It's called MetaTF, post-TensorFlow. And we launched it in April of 2021, so just about a year ago. And since then, we've had over 5,000 unique users start working with MetaTF. But it allows companies to take what they've already developed. They don't have to do anything different. It optimizes their networks in an SNN environment, gets them the highest level of accuracy. And if they're not getting the accuracy they want, there are steps to go back, reprocess it, re-optimize it. And again, that's all automated. So we have that development flow in place. Now, I bring all this up because you asked two questions. You brought up the idea of, I want to do a smart coffee cup. I've come up with a great idea. You guys look like you have a really cool technology. How do I do that? We get a lot of that. Okay. Now, as you know, in the semiconductor space and building out systems, there's a lot of different components to build out a complete system. And we're only a small piece of that. So that's why we partnered with companies like Megachips to enable them to build out a complete SoC to support a customer in their environment. Because you have some companies on the low end that need that support, and you have other companies on the high end that have all the infrastructure, and all they're looking for is the IP and design it in. So it's a very broad ecosystem. And I personally do a podcast on a monthly basis for BrainChip. But what we do is I try to focus on the ecosystem and all the different components that are involved in the ecosystem, because I want people to understand it is kind of fragmented. There's a lot of different players that need to be involved in this. And he who ties out his ecosystem and has all the partnerships and all the relationships is the one who's going to end up winning at the end of the day, because it goes back to trust and being able to solve the customer's problems.
Yeah, for sure. I mean, when you're talking about things being fragmented, I actually just interviewed a guy yesterday for the podcast, and we were sort of lamenting how, I've been in the IoT space for, more than a decade here, probably before it was even called IoT. And, you've got thousands of companies, everything from, low-level chip design, you got fab houses, all the way up to people that are working just on pure applications and APIs and stuff like that. So, in some ways, maybe the reason as to why the Internet of Things, I believe, has been kind of like next year is going to take off. Next year is going to take off, because you have this fragmentation going on, I feel like, and just herding everybody together, it can be very difficult, right? Everyone has their own wants and needs.
Yeah. And in all fairness, it is taking off. It's not, 0 to 1,000 miles per hour in one day. It's ramping up. It's getting widely accepted. We just talked about Alexa, for example. Perfect example. It's built out. The really cool thing is, what's next? And I think, in the next 5 years, our environments and our homes are going to have so much intelligence built into it. For those that want that, there's going to be some really cool applications.
Yeah, for sure. I just don't know if it's on the scale of the 100 billion devices by 2024. Just a lot of these things they were predicting. They were predicting just some pretty insane numbers. And you're right, Alexa's been huge. I mean, if you package it up in something as simple as that, basically a smart speaker, and give it to somebody in their home and they start using it, they will start finding uses for it, right? I think what's been a little bit slow to come, I feel like, is, you mentioned some of the industrial applications and those, there are companies that have bought in and they're in it and they're really sort of pioneers and they're charging them the way forward. And I talk to a lot of companies that are really sort of dipping their toe in this and they don't really know why they're doing it or what is the value. But I think at the end of the day, and I'll bring it back to a positive note, is the more intelligence you can put at the edge, the more power you can do. And so I kind of believe that this whole sort of TinyML, all the work that you guys are doing, all the intelligence at the edge is going to start unlocking a lot of these scenarios that maybe weren't able to be done even, as recent as, 3 to 5 years ago.
Totally agree. And, I'll give you, as you're saying that, I'll give you 5 examples, if I can make it 5. As we go through this, let's take medical devices, for example. The ability to take an image of, let's say, some type of lesion or something to that extent that didn't exist before, and being able to capture that lesion, learn it on a portable device, and then notice that there are now 100 people in a small community that are getting these lesions, and recognize what that is and say, okay, I understand what that is. This technology that's being driven by companies like BrainChip that will be integrated into devices will help us get there quicker. And the ability to detect viruses such as COVID through breathalyzers and other aspects, our blood markers and so on, in a portable world where we don't have to get in lines at large arenas or whatever, or to get tested or something to that extent. And then being able to use those same devices to detect the flu or something to that extent, I think is massive. And we're on the path to do that. The ability to walk into your home, in your kitchen every morning and say good morning towards the kitchen, and your coffee maker turns on and starts making you a double espresso, right? That's more of a luxury than a need. But at the end of the day, people will pay for that. The ability for your refrigerator to recognize that something is rotten by smell. And when more and more refrigerators are going to have panels, on those panels tell you your milk's spoiled or your broccoli is rotten. It's been in there for 3 weeks, whatever it is, The ability for an industrial environment to have vibration detect. And so, there's a defection with a machine that cost $500,000 before it breaks down and stops the whole production line. All of these things can happen today. And all of these things are in the process of happening. When they go to market, when they go to volume, a lot has to be executed upon from that end. And I didn't even get into the good stuff. We didn't even talk about vehicles or drones or flying taxis or all the stuff that's coming our way.
Yeah, for sure. How do you think, this is more of a philosophical question, but I do like to ask people this when they're on the show is how do you think this affects then the future of work? I think about drones, for example. You could have drones go out and do a lot of inspection, a lot of maintenance, right? They're actually, flying and taking a look at with like wind turbines. And that was something that a human would have to do and climb up and take a look at this stuff. They're flying drones up there now to do it. And they're taking all sorts of imagery and they can on device probably do a lot of the stuff that we're talking about. So yeah, how do you guys think much about that, I think? Do you think it's a net positive, net negative, net neutral?
I think it's net neutral. I don't think it's going to change the amount of people that are working. It might change the role of what they do. We're doing some stuff in our office with drone technology right now, and we're tinkering on some pretty cool stuff. It's still going to take someone to operate the drone, to have the drone do what it wants to do, for example. So although, let's use wind turbines, for example, you're not going to need to have a guy risk his life on a daily basis by climbing up a giant wind turbine to do inspection and detection. Now he's going to be operating flying devices, fly up there, capture images of the ball bearings or the main engine area, and then be able to recognize where they need to spend their time fixing turbines. And again, this is a complete hypothetical, right? But for the purpose of and the same thing can go all the way down to an automotive environment and being able to look at engines or components within an automobile and be able to determine wear and tear. And instead of having a mechanic get beneath the chassis to do something, there's going to be all the diagnostics that they can do within, and they're doing some of that today, but all the diagnostics, capture those images, apply it into a system where it could recognize image A looks very similar to this issue over here. So I do think that it's going to be a net neutral. It's not going to replace the amount of activity that we do in the workforce. We will leverage these technologies from that end. There will be areas where you could apply AI and it can, be 90% accurate. But we still find in a lot of the exercises that we do, there's this human element to a lot of what we do that you can't take away.
Agreed. Well said, for sure. You mentioned some of the applications that you guys do. I mean, tell me a little bit more about that. I mean, are you guys just sort of maybe when you talk to customers, are you just, you're coming up with some sort of like a test bed or some sort of example applications? Be like, have you thought about, here's some neat ways in which you can use BrainChip. Is that, you guys have a little lab or a little place where you test out some of these ideas?
We moved to a larger facility at the beginning of the year. And for the first time, we've got a lab and a demo room. It's separate from each other. So we're building a ton of stuff out. The team comes to me with ideas. For the listeners, you can go to our YouTube channel at BrainChipInc. And we have a ton of our media. We have demos that are professionally done, and we have demos that aren't professionally done. And you can see the evolution of the company and how we're going about doing things. But we're doing some fun stuff right now. I mean, one of the things that we talk about that really makes us unique is that we want to be as close to the sensor as possible. And the sensors are what gather that data, that information. And what our AI engine does, or what Akida does, is it takes all that sensor data and it breaks it down and processes the necessary information in a very efficient manner. So one of the things that we focus on are the 5 senses. And those 5 senses are vision. And that's a lot of AI is about vision today. Hearing, very similar to what we talked about with Alexa. And a lot of AI is applied to hearing. But the future of AI really comes down to smell, taste, and vibration. The technology that can manage all that and manage all that on a single working device. And that's one of the things that BrainChip's doing right now is we're demonstrating that by going and looking at some of our media and content, you can see that we're doing vibration detection. You can see that we're doing tactile analysis. You can see that we've got a smell or olfactory and taste. We're demonstrated wine tasting, so you can taste the difference between 2 different types of wine. And we just came out with one where we're demonstrating beer tasting. But, we use beer for fun, and it's pretty cool. We all can relate to that. But the reality is we're not really tasting the difference between two beers. We're analyzing compounds, I should say. And when you think of compounds, you think of glucose, sodium, pH, alcohol, and whatever the compounds are. Those compounds could determine the well-being of a city based off of the water or the gas in the air and so on. So what we're trying to really focus on is with Akida in our technology, what you can do is you can start applying our AI to be as close to the sensors as possible and process this information. And so we have all that, and we're continuing to, as I mentioned before, do more demonstrations and test out technologies, which will allow us to start showing a lot more in the near future. So from that end, what I get really excited about is over the past 2 years, we really haven't had the opportunity to be present and public in a lot of environments like trade shows and where you can really weigh yourself, measure yourself from competitors and other new technologies that are being introduced. And we go to these shows and we're the only ones that can do on-chip learning. We're the only ones that are showing gesture. We're the only ones that are recognizing different facial features. And, then we're demonstrating vibration analysis or high-speed detection of objects and images. And that's where it gets really cool. It's like we're doing all this now. It's proven in silicon. And, now it's just kind of building out the technology, finding the right engagements with the right partners and doing it in a very efficient and effective way.
Yeah, absolutely. That's great. And you talk about sensing compounds. I mean, that is one of the ways that cities know if there's a COVID outbreak happening, right? They're actually testing wastewater for these compounds, which is fascinating, right? So that's all. I mean, it's awesome. And I the other thing I think is very cool is that you guys are actually doing on-chip learning, right? That's the big thing in TinyML was always, or has been, send the data up to the cloud, retrain, send it back down again.
Yeah, it's the one thing that companies haven't been able to get their finger to the pulse on. First of all, finding machine learning guys is really tough. There's a lot of AI guys out there. The second thing is building out the networks for what you want to apply the intelligence to is even tougher. And so it takes guys time to either find a public network and then tweak it to what they want to do or develop their own customized. That could take months to years to do to get it right. So the fact that we're saying, all right, take a network, whether it's your own or it's one that we're, like MobileNetV1. And now let's capture some smells, or let's capture some vibrations, or let's capture some facial recognition. And you don't have to do any retraining. You don't have to get any additional ML learning going on or get the AI. You can allow them to work on other programs and projects. That's where it gets exciting. And it's the companies that can leverage that type of technology, put it into their products, and really build on that for scalability and flexibility purposes.
So any sort of like a turnkey solution, I guess, is what people really, they want to get some sort of a rapid prototype done. They can utilize your stuff for that.
Yes, absolutely. And that's what I think something we get really excited about is the way that we're architected, the way that we've produced the product with the software development flow that we have in place. It's all there.
Yeah, awesome. One of the other things I kind of ask is if people want to get into this field, or like what are some of the shows that you're attending? I guess you mentioned your podcast. I'll be sure to put a link out to that. But what are some good sources of information as people are getting into this space?
Yeah. So anyone interested, I mean, there's 2 points to this. It's, hey, I'm interested in learning more about AI, and then there's, hey, I'm interested in learning more about BrainChip as a company. And then from an AI standpoint, there's a whole show circuit that can be very broad or very specific in nature. And so, for example, you and I we spent some time here, and you've referenced TinyML. And TinyML is a show that takes place not only in the US, but also takes place in different geographies. I know they have a big one in Asia as well. I think that's in the summertime, and our goal is to be there as long as we're allowed to be there. But what we're seeing is, TinyML is really focused on TinyML, tiny machine learning, small technology embedded into other devices. And how do we build on that? As you mentioned, IoT from that end. But there are computer vision, there's embedded vision, there is the AI world. There's a ton of different AI environments for those interested in just learning about AI. I know you mentioned that there's other meetup groups and so on like that. And we'd love to educate and be a part of that and learn as well. In regards to BrainChip, I do send most people to our YouTube at BrainChipInc because that's really where our content is. But our website at BrainChip.com is also a really good place to go. And then if you want a specific conversation, contact us at sales@BrainChip.com and our team will take a look at the question and I can get involved if you reference me to say, I want to talk to Rob. We'd love to have a conversation with you and see what you have to say if you come up with great ideas. And even if we can't support you with your idea, we can at least point you in the right direction of who can support you with an idea that you might have. Because this is a very greenfield environment. It is really wide open. And if I'm going to use in the U.S., we'll talk about baseball, for example. If we're talking baseball, we're in the first inning. I mean, of the whole AI revolution per se, and that's what makes it exciting. There's a lot going on here, and it might feel like it's moving fast to some of us, but it's when we look back 5 years from now, we're going to wow, it's started to move really fast.
Yeah, for sure. No, I've always been on sort of the cutting edge, sort of like the next technology wave. Sometimes in a good way, sometimes a little bit too early. But I do also, realize that, as I've been in this IoT space, kind of in this AI ML space for a number of years here, just the rest of the industry now is sort of like really starting to adopt and come in as a big wave sort of behind me or behind us, I guess, in some ways. And that you're right, you're seeing a lot of these applications now come to fruition. And some of it is sort of this idea that now we actually have the hardware to be able to do the inference at the edge, and now we can train on chip, and now we can run 50% of the power. A lot of these things just weren't able to be done. So it's this great sort of convergence, I think, of sensors from IoT, machine learning from TensorFlow, smarts that you guys are doing with regards to really low power consumption to really make these devices now be able to sort of really act like a human in some ways, right? Actually be able to do intelligence, smart things, and be able to, raise alerts, turn motors on and off, send messages, whatever it is, but, drive the car, whatever it is. So it's a fun time.
Absolutely. One of the things I didn't bring up, we started using this term a few months ago a lot more freely than we have in the past, and that is AIoT, right? That's applying the intelligence to the IoT devices. And so you're going to start seeing that pick up in the world that we live in. Our whole objective is really make sensors really efficient, really smart in very tiny ML type of environments.
Absolutely. Well, cool, Rob. Yeah, you mentioned how people can reach out to you, I guess, sales at brainchip.com, right? And like I say, I'll put links to your guys' website and your LinkedIn page and stuff. That's probably another good place to connect with you as well. Is there any other topics or things that maybe you would want to share that I missed today?
No, I think we're good. I just think that, for those that have a real distinct interest in AI, and, I wanted to just remind everyone that, it is moving at a very fast pace and there's a lot going on out there, and hold on for the ride, because here we go. And for those that are new and they want to learn more, like Justin mentioned, not only with his podcast or other podcasts that are out there, keep learning, be a sponge, and it will all start to make sense over time.
I love it. Yep, for sure. Yeah, the things that I tell people is learn, teach, lead. So learn something new, teach it to somebody else, and then you can become a leader within your organization, whatever it is. But everyone should have an open mind. Well, great, Rob. I definitely appreciate the time today. Thanks so much for being on the show.
Hey, Justin, thank you very much for your time, and look forward to future conversations.
You've listened to another episode of the Conversations on Applied AI podcast. We hope you are eager to learn more about applying artificial intelligence and deep learning within your organization. You can visit us at AppliedAI.mn to keep up to date on our events and connect with our amazing community. Please don't hesitate to reach out to Justin at AppliedAI.mn if you are interested in participating in a future episode. Thank you for listening.